All right, today we're going on a little scientific adventure. We're on a quest to find the perfect recipe for a very special bird, the Gilan native duck. And it's a story all about how questioning a 30-year-old rulebook and changing just one ingredient can literally change everything. Let's get into it.
So, at the very center of all of this is one simple but really powerful question. What if the official diet, the one that's been used for decades, is actually holding these ducks back? What if it's just outdated?
So, meet the Gilan native duck. For years and years, what these ducks ate was based on these really generic guidelines. It was a classic one-size-fits-all approach, but it was never really designed for their specific, unique needs. It's kind of like using a generic cake recipe for every single dessert you make. Sure, it might work, but it's never going to be perfect, right?
And this is the rulebook they've been using. The National Research Council Guidelines from 1994. Yeah, that's over 3 decades ago. For a long time, this was basically the Bible for feeding poultry. But for a special local bird like the Gilan duck, it was really just a best guess.
And you don't have to take my word for it. The researchers behind this study put it perfectly. They said that for this duck, no commercial nutrient recommendations currently exist. That's a huge blind spot in our knowledge, a gap that these scientists were about to fill.
So what do you do when the old rules might be wrong? Well, you design an experiment. Instead of just accepting the way things were, they decided to put the old standard to the test by focusing on one single, absolutely crucial ingredient.
And that ingredient is L-lysine. The easiest way to think about it is as the master protein builder. It's what's called an essential amino acid, which just means the duck's body can't make it on its own. It has to get it from food. It's absolutely vital for building muscle and just, staying healthy. So getting the amount of this one thing right could make all the difference.
So here's the game plan. The researchers took 300 ducklings and split them into 5 different groups. Group 3 got the exact amount of lysine that the old 1994 standard recommended. Groups 1 and 2 got less, and, you guessed it, groups 4 and 5 got more. This setup was perfect because it let them see exactly what happens when you follow the rules and what happens when you break them.
So, what happened? Well, the results were not just a little interesting. No, they were a complete game changer. As it turns out, when it comes to lysine for these ducks, more is absolutely better.
Let's look at the data. This is from the first 2 weeks, a super critical time for a duckling. This chart shows how much weight they gained. See that bar there for group 3? That's the old NRC standard. Now look over at groups 4 and 5, the ones getting more lysine. It's not even close. Right from the very beginning, breaking the old rule led to bigger, healthier ducks. And this wasn't just some early fluke. As the ducks got older, that trend just kept right on going. The ducks that were getting 0.75% lysine, which is well above the old 0.65% standard, gained the most weight, period. The data was crystal clear. There's a new sweet spot for growth, and it's way higher than anyone had thought.
But here's where it gets really cool. It wasn't just about getting bigger. It was about getting more efficient. And to understand this, we need to talk about something called the feed conversion ratio, or FCR. Just think of it like fuel efficiency in a car. A lower FCR number is like getting more miles per gallon. It means the duck's body is way better at turning its food into actual growth.
And that is exactly what happened. The ducks on those higher lysine diets had a much better FCR. So they weren't just eating more to get bigger. Their bodies were fundamentally better at using the fuel they were given. They were basically more efficient biological machines.
So why did this happen? How can one ingredient do all that? Well, the answer is fascinating. The benefits went way beyond just weight. To really get it, we actually have to look inside the duck. And the differences on the inside were just striking. With too little lysine, the duck showed all these signs of poor health, like higher liver weight and more of those bad fats in their blood. But with the optimal, higher lysine diet, it was all positive. Better muscle weight in the thighs and wings, more protein in the blood, and even better blood cell counts. It was a total night and day difference.
And the list of benefits just keeps stacking up. More of that valuable muscle, better fat and protein metabolism, healthier blood, even a healthier gut for absorbing nutrients. At the end of the day, this wasn't just about fattening up ducks. It was about building a fundamentally stronger, healthier bird from the inside out.
So, with all of this powerful evidence, the researchers could finally do it. They could throw out that old 1994 rulebook and write a new one. They had found the new gold standard, a much, much better recipe for growing healthy Gilan ducks. So for those critical first 2 weeks of a duckling's life, the new recommendation is 1.0 to 1.1% lysine. That is a really significant jump up from the old 0.9% standard.
And for the main growing period, that new sweet spot is between 0.75 and 0.85%. Again, way higher than the old recommendation of 0.65. Science had found a clearer, better path forward.
So, what's the big takeaway from all this? Well, first, that old 1994 standard wasn't bad. It was just a good guess based on what we knew back then. Second, rigorous, real-world scientific testing proved we could do a whole lot better. And finally, the new evidence-based standard leads directly to healthier, bigger, and far more efficient ducks. It's that simple.
But hey, let's leave the last word to the scientists themselves. Their conclusion is so clear and direct. For these native ducks, feeding them lysine at levels above the old recommendations is simply better for their health and their productivity. Full stop.
It really makes you think, doesn't it? If fine-tuning one single ingredient in a diet can so completely transform the health and efficiency of an animal, what other long-held assumptions should we be questioning? And what tiny overlooked changes in our own lives or in our systems could end up leading to surprisingly huge results?